Tangents to a circle. Tangent means something very special when we're talking geometry. A point of tangency is when a line touches a circle in exactly one spot. All right, so that is the point of tangency right there. Point of tangency. Okay, if I have two circles, that's not a very awesome circle. But if it is touching both, that would be a common tangent. So over here in this section, we are supposed to draw the points of tangency, and it tells me there are 4. I showed you how to do one. In fact, I'm going to cheat. I'm going to grab my ruler.
Oh, that's not cheating to be able to move.
All right, there's one. Where would another one fall?
At the bottom.
Okay, at the bottom. I'll give you that. So we've got 1, 2. And it's pretty hard to see that those only touch one spot because, you know, of course our pen is going to cover more of the circle. So it is kind of common to put a point. That's where it touches the circle. So where do the other 2 fall?
Will there be one on the right side?
So the right side
So
meaning
like in the center of the right side, so like connecting the two, like
in the center. Okay, you did. You said in the center. I like it.
And then it's going to be the other way too.
And then it will be the other direction. Yep, you guys are good. So there's one. Oops, that kind of scooted over. We'll just make that point extra big. And then there would be one going the other direction. Good work. A lot of classes really struggle with seeing that those 2 would be there. So good work.
and that's any other place on the circle in order to, because those are the only other 2 ones that they could be, because any other place on the circle.
It'd go through the circle, right? So we did practice Pythagorean theorem for a reason, because anytime we're talking about points of tangency, tangent lines with a circle, we always end up with a right angle. Right angles and triangles, we've got that theorem that makes it easy to solve for lengths. And so anytime we have a point of tangency, it's going to be perpendicular to the radius. They might even draw the diameter. It'd be perpendicular to the diameter as well. So if it shows us the point, and when we've got a line coming from or through the center, it's going to be 90 degrees. That's just a given. So over here, it tells me AB is tangent, which means it touches that point. Which if I've got the radius, what kind of angle do I know is right here? 90-degree angle. So how do I determine, oh, it doesn't tell me it's tangent. It says determine whether it's tangent. So that's what's in question. Is it a 90-degree angle?
Wait, hold up.
Ready, ready.
I'm confused. Wait, never mind.
You got it?
Let's see if I get it.
So Friday, let me leave the class there just a second. Friday, we had a method of determining if something was a right triangle or not. Megan, your hand was up first. What did we do?
We took the legs A and B, and then we added them together. So we did, in this example, it would be 8 squared plus 6 squared. Does it equal?
All right, so we're going to see if the leg squared plus the leg squared equals the hypotenuse squared. All right, so 6 squared plus 8 squared. We're seeing if that is 10 squared. That's a 36. That's a 64. That's 100. Is that true?
Yes.
So is AB tangent?
Yes.
Because we have a right triangle. All right. Here's another theorem you will be using today. I have a point, and from that point, I've got two tangent lines. It tells me that because I see the point there and there. Now this is the theorem you need to know. If we're coming from the same point and it's tangent, those pieces have the same measure. They're congruent. So now we'll apply that over here. It wants us to solve for m. I've got a point, tangent line, tangent line. So what do you know about the length of each of those? They're congruent. So I can say 2m plus 9 equals 3m plus 6. Take away 2m. Take away 2m, take away 6, take away 6 equals 3. Now, you know how the past couple of times the theorems feel pretty darn friendly, but then you get in your homework and it seems way crazier than what we were doing? Why don't we take just a second and do a couple of homework problems just so you're familiar with what they look like. And of course it logged me out. Of course it did. So give me just a second and we'll do some of your homework problems. I do have 6 new problems and 4 review from the Thursday information. So you'll look back in your journal for those last 4 problems. And the first 6 are today's assignment. So let's see, start. Does it already look scarier than what was in our journal? Yeah? Screams of terror. So again, remember, I have these markers over here that you're either going to draw it on the paper so I can write on your paper, or you're going to draw it on your screen so I can write on your screen, right? You need to have things labeled when you ask me for help. So let's go through and see what I've got here. In fact, it's already got the measurement. OF is 12. There it is. And OE is 17. And that's clear all the way through from here to the end. So you've got to pay attention to what we've got going. The whole thing is 17.4. And it wants to know EG. This is the one we want to know right here. Does anybody, Mia, go ahead. I saw your hand first.
Okay, so would we use the Pythagorean theorem for this one?
Where's my right angle?
Oh, no, you don't have one.
Don't I?
Is it not like right there?
You? It's over.
So it tells me that EF is a tangent. Because I know that this line is tangent, and this is a radius right here. So tangent, radius, that means I have a right angle right there. So you're right. Finish your thought.
Okay, and then it would be 12 squared, with we don't know what B would be.
So I know this leg, but I don't know this leg.
Yeah. And then it would equal 17.4.
I'm just going to call it leg squared and equal 17.4. Okay, why am I wanting to solve for this piece right here when I want to know?
It's equivalent to EG.
They're the same.
They're the same. They're congruent. So I need some help. I need to know what 17.4 squared is.
302.76.
All right, now take away 144 for me.
158.76.
And now we need to square root that one.
12.6.
12.6? So we just solved for this. This is 12.6, which means
That would be equal.
that is 12.6 because they come from the same point and they're tangent.
Actually, that's easy.
Yeah, it's just understanding what they're asking, right? So it feels feels like we're doing all right with that, I would like to show you the second type of problem. So you guys don't yell at me that you need to show us how to do this.
We still will.
I know. It's just part of it. All right, so let's label this one. DG and DE are tangent. So that means that's a right angle, right? Because I've got this radius right here. And then what else do we know? DG is 3, which is the whole thing.
And then we know.
GE is 1.8. And we want to know this little guy right here. That one looks kind of weird, doesn't it?
Yeah.
Now, what I want you to focus on is this triangle right there. Could I figure out, what could I figure out?
You could figure out.
Could I figure out this missing side?
Yeah.
Does that help me? If I know this missing side, how does that relate to anything else in our picture? Do I have a point out here that is tangent to my circle? Is it tangent here and here? So what do you know about this length and this length?
Let's see.
They're the same. So let me show you what we're going to do. You're watching this one, right? So you know how? All right, so we've got a leg squared that we don't know, plus 1.8 squared equals 3 squared. Solving for this leg right here, right? What's 1.8 squared?
3.24.
3.24 equals 9. Take away 3.24 for me.
5.76.
Yeah.
And square root that. 2.4?
Yeah.
All right, so this guy is 2.4, which means this guy is how long? 2.4.
Oh, and then you subtract that
And
by
then you
3.
Now I want to know
Right.
that guy. If the whole thing is 6 and this part is
So
2.4 and
it's-
this one
it's
is...
0.6.
Ready, set, go? All right.
Ready, set, and go. Go.
Yeah.